Place your hand on your chest right now. Feel that? Your heartbeat, steady rhythm. Pause, pause. That pause between beats feels like nothing, like empty time, like a brief moment of stillness before the next contraction begins. You think nothing happens in that gap. You think it is just waiting, just dead space between the important events. You are catastrophically wrong. Between two heartbeats, your reality is being rebuilt from scratch billions of times per second. Between two heartbeats, the atoms in your body are vibrating, colliding, exchanging energy in ways so complex that no computer on Earth could track them all. Between two heartbeats, light is bouncing around the room roughly 900 million times. Between two heartbeats, the universe is performing calculations so sophisticated that they make every human computer look like an abacus made of rocks. Richard Feynman spent decades studying what happens in the spaces between things, between particles, between moments, between measurements, and what he discovered will completely destroy your intuitive sense of time. Because time is not what you think it is. Time is not a smooth flow from one moment to the next. Time is not a river. Time is not even continuous. At the smallest scales, time might be quantized, chopped into discrete pieces. And between those pieces, reality itself becomes uncertain, probabilistic, and genuinely strange. Let me show you what I mean. Your heart beats roughly once per second. Let us say 0.8 seconds between beats. That feels like 1 unit of time, one event to the next. But to a physicist, 0.8 seconds is an eternity, an almost incomprehensibly vast amount of time during which countless events occur simultaneously. Light travels 240,000 kilometers in 0.8 seconds. That is roughly 60% of the distance from Earth to the Moon. In the time between your heartbeats, a photon could travel from New York to Tokyo and back 7 times. But forget light. Let us talk about something much faster. Let us talk about electrons. The electrons in the atoms of your body are not sitting still. They are not orbiting the nucleus like planets around a star, despite what your high school textbook showed you. Electrons exist in probability clouds. They are simultaneously everywhere they could possibly be until something forces them to pick a location. And those probability clouds are constantly shifting, vibrating, interacting with neighboring atoms at frequencies measured in quadrillions of cycles per second. Between two heartbeats, the electrons in your body complete roughly 1 quintillion oscillations. That is a 1 with 18 zeros after it. 1 million trillion vibrations between thump and thump. Each oscillation is a chance for something to happen, a chance for energy to transfer, a chance for a chemical bond to form or break, a chance for a photon to be absorbed or emitted. Your body is not a static object between heartbeats. Your body is a raging storm of quantum mechanical activity happening at speeds your conscious mind cannot even begin to process. And it gets stranger. Feynman understood something most people miss entirely. He understood that particles do not just sit around between measurements. They do not just occupy one path from point A to point B. According to quantum mechanics, according to the mathematics that accurately predicts every experiment we have ever run, particles take every possible path simultaneously. An electron moving from one side of an atom to another does not travel in a straight line. It travels along every possible route at the same time, and only when you measure it does it retroactively pick which path it actually took. This is not metaphor. This is not philosophy. This is the mathematical description that gives us correct predictions. Between any two moments when you observe a particle, that particle exists in a superposition of all possible states. It is here and there and everywhere in between simultaneously. Only measurement collapses the wave function and forces reality to pick one specific outcome. Between your heartbeats, every electron in your body is doing this, existing in multiple places at once, taking every possible path through its probability cloud simultaneously. Feynman developed a mathematical tool called the path integral formulation to calculate what happens between measurements. And the answer is genuinely bizarre. The universe does not calculate which path a particle will take and then move it along that path. The universe calculates every possible path, assigns each path a probability amplitude, adds them all together, and only then determines what you will observe when you look. Between any two measurements, reality is trying out every possibility simultaneously. Now bring this back to your heartbeat. Between one beat and the next, the universe is not just coasting along waiting for something to happen. The universe is actively computing every possible state of every particle in your body. Electrons are exploring every possible position. Photons are bouncing in every possible direction. Chemical reactions are simultaneously succeeding and failing until observation collapses them into one definite outcome. You think the pause between heartbeats is empty. The pause between heartbeats is the busiest, most computationally intense moment you can possibly imagine. But here is where Feynman went even further. He asked a question that most physicists were too scared to ask. What if the space between moments is not smooth? What if time itself is not continuous? What if there is a smallest possible unit of time, and below that scale, the concept of before and after stops making sense? This idea is called the Planck time. It is roughly 0.0000000 devastated. 0.0000000 da 0.0000000 da 0.0000000 da 0.0000000 da 0.0000000 da 0.0000001 seconds, 10 to the negative 43 seconds. At the Planck scale, our current understanding of physics breaks down completely. Space and time become quantum foam. Causality becomes uncertain. The smooth fabric of space-time we experience might actually be made of discrete chunks, like pixels on a screen, and between those pixels nothing exists in any meaningful sense. Between two heartbeats, roughly 10 to the 43 Planck times occur. That is 10,000 billion moments. Each one a potential opportunity for quantum events to occur. Each one a slice of reality so thin that our best theories cannot describe what happens there. Feynman loved thinking about this. He loved the idea that between any two observable moments, an entire hidden universe of activity occurs. A universe we can only describe mathematically. A universe we can never directly observe because the act of observation changes what we are trying to see. Your heartbeat divides time into human-scale chunks that feel natural and intuitive. But between those chunks, reality operates on scales and at speeds that your conscious mind was never designed to comprehend. You are not experiencing time as it actually is. You are experiencing a heavily filtered, massively downsampled summary of incomprehensible complexity happening beneath your awareness. Now let me tell you what is actually happening inside your body between heartbeats. And I mean actually happening, not the simplified cartoon version they taught you in biology class. Every single cell in your body is a chemical factory running thousands of reactions simultaneously. Between two heartbeats, roughly 60 trillion chemical reactions occur in your body. 60 trillion molecular transformations. Bonds breaking, bonds forming, electrons jumping between energy levels, protons tunneling through barriers they should not be able to cross. That last part deserves attention. Quantum tunneling, one of the strangest predictions of quantum mechanics, and one that Feynman helped explain mathematically. In classical physics, if a particle does not have enough energy to overcome a barrier, it cannot pass through. Simple, intuitive, wrong. In quantum mechanics, particles have a probability of appearing on the other side of barriers even when they do not have sufficient energy to climb over them. They tunnel through. They just appear on the other side as if the barrier did not exist. This is not rare. This is not exotic. This happens in your body constantly. Between heartbeats, protons are tunneling through energy barriers in your mitochondria, generating the ATP molecules that power every cell in your body. Without quantum tunneling, you would die instantly. Your metabolism depends on quantum mechanical effects occurring trillions of times per second. The energy that keeps you alive is being generated by particles doing things that classical physics says are impossible. You are a quantum mechanical system pretending to be a classical object. Feynman understood this better than almost anyone. He understood that the boundary between quantum and classical is not sharp. It is not like quantum mechanics applies to tiny things and classical mechanics applies to big things. Quantum mechanics applies to everything, always, at all scales. It is just that large objects involve so many particles that all the quantum weirdness averages out into something that looks classical. But between heartbeats, in the microscopic machinery of your cells, the quantum nature of reality is fully exposed and actively doing work. Let me give you another example. Photosynthesis. Plants convert light into chemical energy. You probably learned this in school as if it were a simple chemical process. It is not simple. It is stunningly sophisticated quantum computation. When a photon hits a chlorophyll molecule, that energy has to be transferred to the reaction center where it gets converted into chemical form. The molecule has to find the most efficient path through a complex energy landscape. And it does this using quantum superposition. The excitation energy exists in multiple places simultaneously, sampling every possible pathway through the molecule at once, finding the optimal route through quantum interference effects, and completing the transfer with 95% efficiency. This process takes less than 1/1,000,000th of a second. Between two of your heartbeats, plants around the world complete roughly 800 trillion quantum computations to convert sunlight into the oxygen you breathe and the food you eat. Reality is performing quantum algorithms constantly, and you never notice because your conscious perception operates on timescales millions of times slower. Now think about your brain. Between heartbeats, roughly 80 billion neurons in your brain are firing, communicating, adjusting their connections. Each neuron connects to thousands of other neurons through synapses. Each synapse is a gap roughly 20 nanometers wide. When a neuron fires, it releases neurotransmitter molecules that diffuse across this gap and bind to receptors on the receiving neuron. This happens in roughly 1 millisecond. Between your heartbeats, hundreds of billions of synaptic transmissions occur. Your thoughts are not smooth. Your thoughts are discrete packets of chemical and electrical activity firing in coordinated patterns, too fast for you to perceive as separate events. But even that description is too slow, too classical. Feynman would ask, what happens in the space between synaptic transmissions? What happens in the nanoseconds while the neurotransmitter molecule is crossing the synaptic gap? And the answer is quantum mechanics. The molecule does not take one path across the gap. Takes every possible path simultaneously. Its trajectory is a superposition of possibilities that only collapses when it binds to the receptor. Your consciousness emerges from quantum mechanical processes occurring at scales and speeds you have no direct access to. Here is something even stranger. Your DNA, the molecule that contains the instructions for building your body. DNA is roughly 2 nanometers wide. Between heartbeats, cosmic rays and background radiation are constantly hitting your DNA, causing damage. Roughly 1 million DNA lesions occur in each cell in your body every single day. That means between heartbeats, roughly 9,000 DNA damage events occur. 9,000 moments when a chemical bond breaks or a base pair gets corrupted. Your cells have sophisticated repair mechanisms that fix most of this damage before it causes problems. But how do those repair mechanisms work? They work by quantum tunneling. Repair enzymes scan along the DNA strand, and they can detect damaged bases because the quantum mechanical properties of damaged DNA are different from healthy DNA. The electron clouds have different shapes. The vibrational frequencies are different. The enzymes are reading quantum information and responding to it. Between your heartbeats, thousands of quantum measurements and repairs are occurring in every cell, maintaining the integrity of your genetic code against constant quantum mechanical assault from the environment. Feynman loved these examples because they show that quantum mechanics is not some abstract mathematical formalism that only applies to particles and accelerators. Quantum mechanics is the operating system of reality. It runs constantly. It runs everywhere. And it runs fastest in the spaces between the moments you consciously perceive. Your experience of time is like watching a movie at 24 frames per second. You see smooth motion, but between the frames, The universe is performing calculations at speeds measured in femtoseconds and attoseconds, quadrillions of operations between each frame. And here is the truly unsettling part. You cannot speed up your perception. You cannot see what happens between heartbeats by paying closer attention. Your neurons fire at maximum rates of about 1,000 times per second. That is your frame rate. That is your resolution. Everything happening faster than 1 millisecond is invisible to your direct conscious experience. It is not that you are not looking carefully enough. It is that your hardware cannot process information faster than that. You are biologically locked into a low temporal resolution view of reality, and between your samples, the universe is doing things you can never directly observe. Feynman proved mathematically that this hidden activity is not just random noise. It is structured. It is meaningful. It obeys laws. And most importantly, it is essential. Without the quantum activity happening between moments, moments themselves could not exist. The macroscopic world you experience emerges from the microscopic quantum world operating at speed your consciousness cannot access. You are like a person watching a computer screen, seeing the final rendered image, completely unaware of the billions of calculations happening inside the processor between each pixel update. Between your heartbeats, reality is computing itself into existence. So what does all this mean for your experience of time? What does it mean to know that between every moment you consciously experience, trillions of quantum events are occurring at speeds you cannot perceive? Feynman had a fascinating answer to this question. He said that continuous time is an illusion created by insufficient resolution. Like watching a movie and thinking the motion is smooth, when really it is discrete frames playing fast enough to fool your brain. Think about digital music. When you listen to a song on your phone, you think you are hearing continuous sound, but you are not. Digital audio is sampled at 44,100 samples per second, 44,000 discrete measurements of the sound wave every second, and your brain stitches them together into the illusion of continuous music. Between those samples, nothing exists. The sound is not continuous. It is quantized, chopped into pieces. But the pieces are small enough and fast enough that you cannot tell the difference. Feynman suspected that time itself might work this way, that what we experience as smooth, continuous time might actually be discrete moments happening so fast that they blur together into apparent continuity. The Planck time might be the sample rate of the universe, 10 to the 43 samples per second, vastly faster than anything biological systems can detect, creating a perfect illusion of continuity. Between heartbeats, roughly 10 to the 43 Planck moments occur. And if time truly is quantized, then between those moments, literally nothing happens because there is no between. There are only the discrete moments themselves. This idea terrified some physicists and delighted others. If time is quantized, then the universe is more like a cellular automaton than a smooth manifold. Reality would be computing itself forward, one Planck moment at a time, updating the position and state of every particle, then moving to the next moment. The universe would be running on a clock. An impossibly fast clock, but a clock nonetheless. And between clock ticks, the concept of time would be meaningless. There would be no flow, no passage, just discrete state updates happening in sequence. Feynman never committed to this interpretation fully because the mathematics was not developed enough in his lifetime, but he loved the implications. He loved that it suggested time is not fundamental. Time is emergent. Time is something that appears when you look at quantum systems from a distance, averaging over countless Planck moments, seeing patterns that look like smooth change but are actually discrete jumps too fast to resolve. Your heartbeat spans 10 to the 43 moments. Your conscious perception integrates over billions of quantum events per second and presents you with a simplified summary that feels continuous. But what happens to causality in this picture? If time is discrete, if the universe updates in steps, then cause and effect become more complicated. Between moments, particles exist in superposition. They have not decided what to do yet. Only when the next moment arrives does the wave function collapse and reality pick specific outcomes. This means the future is not determined by the present in any simple way. The future is determined by quantum probabilities that get resolved moment by moment as the universe computes forward. Feynman's path integral formulation captures this beautifully. Between any two measurements, the particle takes every possible path, and the probability of each final outcome depends on the interference between all those paths. The universe is constantly branching into possibilities, calculating probabilities, collapsing wave functions, and moving forward one Planck moment at a time. And you, with your slow biological perception, see only the final averaged result. You see the movie, not the frames. You see the song, not the samples. You see time, not the discrete moments. Now, bring this back to your body one more time. Place your hand on your chest again. Feel that heartbeat. Between this beat and the next, your body will perform roughly 1 quintillion quantum operations. Light will travel 240,000 kilometers. Electrons will oscillate through probability clouds 1 million trillion times. Chemical reactions will create and destroy trillions of molecules. DNA will be damaged and repaired thousands of times. Neurons will fire hundreds of billions of synaptic transmissions. And if time truly is quantized, 10 to the 43 discrete moments will occur, each one a complete state update of every particle in your body. All of this happens in what feels to you like a brief pause, a moment of stillness. Nothing happening, just waiting for the next beat. But Feynman showed us that nothing could be further from the truth. The pause is not empty. The pause is not stillness. The pause is reality. At maximum activity, computing itself forward at speeds that make the fastest supercomputer look frozen in time. You are not experiencing time as it actually is. You are experiencing a heavily compressed summary designed to be useful for survival, not accurate for understanding. And here is the final disturbing implication. If you cannot see what happens between heartbeats, if you cannot access the Planck scale moments where reality is actually doing its work, then you cannot claim to understand time at all. You only understand your perception of time. You only understand the illusion your brain creates. The real nature of time, the discrete quantum mechanical updating of reality moment by moment, remains forever hidden beneath your perceptual threshold. You live in a low-resolution simulation of reality, and between the pixels of your experience, the universe is running calculations you can never witness. Feynman understood this. He understood that physics reveals a reality far stranger and far more active than common sense suggests. Between any two moments you consciously experience, an entire hidden universe of quantum mechanical activity unfolds. And that hidden universe is not secondary or less real than what you perceive. That hidden universe is the foundation. What you experience is the summary.
The compressed file.
The lossy approximation. Between your heartbeats, reality is being computed into existence. One Planck moment at a time, and you will never see it happen because your frame rate is too slow. You are living in the spaces between quantum moments, and those spaces contain more activity than your conscious mind can possibly imagine.